Hello, welcome back to my YouTube channel. So today we are going to learn about limiting case of Poisson distribution to normal distribution or else normal distribution to Poisson distribution. Okay, so already I did a video related to binomial distribution to normal distribution. If anybody did not watch that one, so you go and watch that one. So now I am going to discuss about Poisson distribution to normal distribution. So first we have to consider that proof. First we'll write the statement. So statement, Poisson distribution turns TENDS turns to normal distribution. Poisson distribution turns to normal distribution as lambda turns to infinity. Okay, so as lambda turns to infinity, so the Poisson distribution becomes normal distribution. So previously binomial distribution we have learned about n turns to infinity. So here lambda turns to infinity. Why? Because in Poisson distribution we are having only one parameter, that is lambda. So that's why if lambda turns to infinity, that automatically turns to normal distribution. But whereas in binomial distribution, there we are having two parameters n and p. So n turns to infinity. If n turns to infinity, automatically the binomial will turns to normal distribution. So that's why here it is having only one parameter. That's why we have written here lambda turns to infinity. Okay. So proof. So we all know that Poisson distribution mean and variance are same. That means lambda. So Poisson distribution has having mean lambda and variance also lambda, and the parameter also lambda. So Poisson distribution is having lambda parameter, lambda mean, lambda variance. So the moment generating function of Poisson distribution is mx of t equals to e power lambda into e power t minus 1. So this is moment generating function of what? Poisson distribution with respect to x. Okay, so now the standard Poisson variable or variate. The standard Poisson variable is z equals to standard in the sense here definitely the z variable will come. Okay, so z equals to x minus expectation of x by square root of variance of x. So e of x is nothing but mean, v of x is nothing but variance. So we all know that in Poisson distribution mean and variance are lambda. So that's why we will substitute here mean and variance values. That means z equals to x minus lambda by root of lambda. So this is nothing but z value. So now what we have to do is we have to write this moment generating function in terms of z. Why? Because here z value we are having and normal distribution we are discussing. That means Poisson turns to normal. So in normal we are having the z variable. So that's why here moment generating function should change into z. Okay. So the moment generating function of z is given by mz of t. Instead of x we are going to write z. Mz of t equals to expectation of e power tz. Okay, expectation of e power tz. So that equals to expectation of e to the power of t into z. In place of z what we have to write is this value. So this is z value, no? So that means x minus lambda by square root of lambda. Okay, so now we have to separate this term by multiplying with t. Okay, so we are going to separate these terms. So expectation of e power tx by root lambda minus t lambda by root lambda. Okay, so here we all know that here it is in the form of e power x minus y. So that's why we have to write here e power x into e power minus y. In the same way we are going to write this term. Okay. So that means mz of t equals to expectation of e power tx by root lambda into e power, what is there, e power minus t lambda by root lambda. Okay, so now we have to multiple this expectation with these both terms. But we all know that whenever there is a variables, we have to take expectations, otherwise we should not take. So so if we see here we are not having any variables. Okay now, so here we are not having any variables, that means x, y variables we are not having, only this term we are having. So that's why we are going to take this term as a constant. Okay, so e to the power of minus t lambda by root lambda into expectation of e power t x by root lambda. Okay, so now what we have to do is, now if we cancel this one, root lambda will go in lambda, root lambda times. Okay, here the remaining term is e to the power of minus root lambda into t. Okay, and the next is, if we see this one, it is in the form of m x of t, mx of t, but where the t term is, what is the t term is, t by root lambda, that means mx of t. So we are going to write here m x of t, t in the sense what, t by root lambda. Okay, see here mz of t equals to, we have written like this. Now we have here what we did, it is in this form, we did this form. Okay, so that equals to e to the power of minus root lambda into t into, here we all know that mx of t is nothing but e power lambda into e to the power of t minus 1. So we are going to write this term here. Okay, so e power lambda into e power t, but here we are having t value as t by root lambda. Okay, so t by root lambda, here minus 1, so minus 1. Okay, so and the next is, now what we have to do is, now we have to applying log on both sides. Okay, applying log on both sides. So what we get is log mz of t, log mz of t equals to log of what, expectation of, sorry, log of e to the power of minus root lambda into t into e power lambda into e power t by root lambda minus 1. Okay, so now what we have to do is here log a into b. Log a into b formula is what? Log a b. Formula is nothing but log a plus log b. Okay, so we are doing here the same formula we are going to implement. So log of a in the sense what, this one, e to the power of minus root lambda into t plus log of e power lambda into e power t by root lambda minus 1. Okay, so this is log a plus log b. Okay, so now what, now we have to simplify this one. Log e, both gets cancelled, so the remaining term is minus root lambda into t plus, here log, here e, both gets cancelled, so lambda into e power t by root lambda minus 1 is the remaining term. Okay, so now what we have to do is, here it is in the form of e power x. We all know that what is the e power x formula. So e power x formula is, so we all know that e power, it is in the form of e power x. So e power x formula is e power x equals to 1 plus x by 1 factorial plus x square by 2 factorial plus and so on. Okay, so now we are going to take this term in this way. Okay, so log mx of t equals to, here minus lambda into t plus lambda. So here e power x, it is in the form of e power x. So we are going to take this formula. In this way we are going to substitute this one. Okay, so bracket we are taking. So e power x, x value, what is x value? T by root lambda. So first we are having 1 plus t by x, in the sense what? T by root lambda into what? 1 factorial. 1 factorial is nothing but 1 plus, next is what we are having? T squared by root lambda square. So t square by root lambda whole square into 2 factorial plus and so on. Okay, so at last we are having what? Minus 1. So minus 1 we are having. Okay, so here if we see, so and the next is, we have to simplify this term. So if we simplify this term, so that equals to minus root lambda t plus, here, see here, bracket I am going to keep here. Why? Because this lambda belongs to this minus 1 also. So that's why I am going to take this bracket outside of this one. Okay, so here if we observe, here this one and this one get cancelled. So the next term is lambda into t. Lambda into t by root lambda plus lambda into t square by 2 factorial is nothing but 2. So here root and square get cancelled. The remaining term is lambda. Okay, so plus and so on. So now what we have to do is, here log mz of t, no? So here if we see, root lambda, it goes in lambda, root lambda times. So the next term is minus root lambda t plus root lambda t plus lambda in lambda also get cancelled now here. So the remaining term is t squared by 2 plus and so on. So these two get cancelled. So the remaining term is t squared by 2 plus and so on. So I told you in previous video, when we discussed about Poisson distribution, we should not consider all the terms. We just want only t squared by 2. Why? Because this is a standard normal moment generating function term. So that's why we have to consider only t square by 2. We want only this. We don't want any other. We should not bother about all the terms. Okay. So here log mz of t. So the next is, now what we have to do is, we have to apply limit and lambda turns to infinity. Okay. So limit lambda turns to infinity, log mz of t equals to limit lambda turns to infinity t square by 2 plus and so on. Okay, so here limit lambda turns to infinity, so log, here we are having what? Log. So log, if we take from this side to this side, it becomes what? So mz of t equals to log, if we take from this side to this side, it becomes what? E power t square by 2. Okay, so therefore what we got, so nothing but this is what? Moment generating function of standard normal variable or variate. Okay, so we have proved what we took here. Here we took standard Poisson variable and we got at last moment generating function of standard normal variable. Okay, we took Poisson distribution and we got normal. So that means these both are having what? If lambda turns to infinity, so Poisson will turn to normal variate. So hence proved. So this is very important. If you go through 2 times, you will get easily. So don't lose your marks. If you practice 2 times, it will be very good for you. And if you learn this one, Poisson will be easy. If you learn Poisson, binomial will be easy. If you learn binomial, Poisson will be easy. Why? Because the same procedure it will be having. First you have to take z, and then you have to take log, and then you have to take what? Limits. Okay, so practice it, don't lose your marks. So thank you for watching. If anyone are newly watching, please subscribe to my channel and don't forget to like and share with your friends. Thank you. Have a nice day. Bye.